Okay. And Tuba Guntar. Okay. Daniel. Kalapati. George. And here. Gogulamudi. Gunai. Gunage. Okay. Gunage. The Sai Mahidhar Reddy Irui. Navin. And Kavri. Okay. Devi Priya. And the Vansanti. Okay. Lan. See how Lan. Okay. That's me. Lei. Meaning late. You took my course before.
Yes.
Which one?
Last spring.
Last spring. Which one?
Huh?
Which class did you take my course?
A same class.
So you retake?
Yes,
okay.
retake.
Because it looks like the familiar.
That's great. It's not good.
Okay. Good luck.
Thank you.
Madineni. Okay. Debbie. And Dandawathima. No. Manumari. No. Salah. Mustafa. And Sajad. Okay. Arlim the Muji. Okay. Venkata. The Nadiwada. O'Brien, he's the here. Samausil. Okay. Are you underwrite it? Yeah. Did you take my course before? No. I have a Joshua the last semester. And I'm very familiar with your face. Parat and Parik. Rabar Pater. Kartik Pater. Shreya Pater. Leonardo Posa. Okay. Sabrahars the Rabbit. Okay. Rajendra. Okay. Scott. And Shran Sethi. Harsh. Sepalia.
Oh, that's me. Not, I heard something else.
Okay. Dandy Taylor. Srikanth. Totam. Owen. Kunyan Shao is T. Yu Shenyang. And Leodida Jeta.
Yeah.
Jeja. Okay. Okay, so as you can see, it takes a long time to call your name. So maybe the couple of times more, the later, but the most of the time, your attendance will be checked by the pop-up quiz. So if you miss the quiz, the missing quiz, and the missing attendance. So however, I do not blame if you do, even though you missed the class or if you do not attend the class, because you are not the elementary student. So one of my friend who got the degree the same time, actually he got the master degree within 11 months. So he took the three course, then in summer 4 courses. Then the guy got the master degree 11 months. Then most of the time he didn't attend the class. He got the excuse from the professor, but he lose the attendance point. But he studied by himself because he believed he learned the most of the subject in the undergraduate. Then he focused on more research, and because to graduate within the 11 months, but I don't blame him, and he successfully finished, and when he got the PhD, right now he is chair of the department in Arkansas. So it's, you don't have to be sorry even though you missed the class. It's your responsibility, okay? You are adult and you are full, I believe, responsible for yourself, okay?
Oh, you didn't call my name. You didn't call my name. I think it's not there.
Which one? Your
My
name?
Yeah.
Which means when do you register? So I think it takes 1 or 2 days to be updated, okay? So don't worry, I do not check the attendance today, so don't worry, but you need to check the Canvas. If your name, if you cannot see the course list, the enrolled course list, contact the registrar office or the mostly is automatically, okay? Any other who has a problem for the enrollment? And if you want to register the later this class, so you can bring the paper form, then I can give my signature. Okay, so any other questions before we start the lecture today? Okay, thank you. And I forgot to bring with my. Okay, I forgot to bring my pointer. So it's 10:45, right? Yes. What is this? How do you know that? So this is a rectangle. So in this class, the rectangular indicate the computer. So our major, my major, your major is in computer science or computer engineering. It's not exactly the same, but anyway, in terms of the main target that we are dealing with, that is a computer, so it's a computer. So what is a computer, by the way? Have you ever thought about your major? So my major is computer science, so then what is a computer, by the way? Computer is?
Machine that does calculations as well as.
Very nice definition. So one time I asked my daughter, she is a senior and applying a lot of the university, but this year is really tough to get the admission because you know the millennium baby. So 2000, actually there are 20 to 25% more the newborn baby in 2000, which affect the admission. Oh, really? So if you ask if you have the sibling or if you have a friend who are applying, this year really tough because of the millennium baby. So, but anyway, she tried to major in computer also. Yeah. I'm not sure whether that is good choice or not, but she tried to apply the computer science and the computer. Good news is she tried to understand what her daddy is doing. But the bad news is most of computer science department or the computer science major or the engineering major has a little bit higher the expectation, the admission, the criteria higher than the other subject, which is good for you. So, but I asked her, can you live without computer? which means the cell phone. So cell phone is a computer. So, or directly I asked her, can you live without parents? And or can you live without your cell phone? If you need to select either of them, but her answer is, surprisingly, the cell phone is more important. Anyway, she will live from the parents. So maybe the wherever she goes to, she got the admission anyway. She will live without without the parents, but she cannot live, survive without the cell phone. Which means I don't blame my daughter, but so a little bit disappointed, but that's really true. So think about what you have done. Well, many of you are international students. So what did you do? What was the first thing you did when you arrived the U.S.?
Number.
You need to get the SIM card.
Yes.
That's the first thing. When you travel to the start of the road or the travel to any country, first thing you need to do is to connect. Okay? So without the computer, we cannot imagine to survive in this era. So it is true. This is really the computer-related era. So and this is good news. We are studying about the computer. By the way, what is that computer? That's the basic and the important thing. She defined the very basic thing. Computer is like the teacher. What is a teacher? Who is a teacher? A person who teaches, right? Which means computer is a person who computes. So we try to compute something, but it's not a person, it's a machine. Historically, the human being would like to speed up for the calculation. So long time ago, like 5,000 years ago, we had a computer also. What is that? It's called the abacus. I thought the abacus is from China, but it's Babylonian actually. It's different. It's not the China. So abacus is like some like that. I'm not good at to use in the elementary school, the math class, we learn how to use this kind of thing. So we can calculate. Still there are competition in the East Asia to use this kind of thing. It's called abacus. Abacus is one of the oldest computer stuff. We can calculate the number very fast. That is the main purpose of the computer. So historically, for example, Leibniz and a lot of inventor and philosopher that try to develop the new and the better, fancy, faster the calculator. Okay, but most of them are without electricity. It's just the gear and other thing. So recently means the 100, maybe the less than 100 years. So we try to use electric power for the calculation, for the calculator. So it has been changed to the without power, we have a power. So nowadays we consider the computer as something device, electronic device that can calculate. Calculate what? Just a number? So more than that. So computer is something electronic device that can calculate, that can process data or sometimes information. We will talk about this one a little bit later. Then that device consists of the several important stuff, as you have learned in the computer architecture class. What is kind of common sense? What kind of thing in the computer? First, CPU is the most important part. So in your microprocessor class and computer architecture class, you learned about what is a CPU. And what is a CPU, by the way? It's a central processing unit. It's the brain of the computer. is the most important part of the computer that can process, calculate. It's almost the same thing. Calculate something. That something is this one, and the unit. Okay, that is the CPU, like the Intel, AMD, and so on. Then that process what? Just data, information. Specifically, what kind of data? What kind of information that the CPU can calculate? Binary. More details. It's an instruction. So actually, the CPU can process only the instruction, which means when the manufacturer of the CPU developed the design, the CPU, they define like the plus, minus, and so on, like the move. And that, I'm not very good at assembly, but you are much better than me because you already took the microprocessor class, right? So it's such an instruction are defined, and the design, hardware, as a hardware is a design in the CPU. Okay, so CPU can only calculate this one. Actually, they are based on the binary. So we will talk about later the one about such a what is a binary. Not details. This you already learned the data structure. So this is based on such an instruction. Then the computer program or any other, they are coded by such a instruction, like assembly language, machine language. Okay, like for example, if you are using the Java, so Java will be compiled and converted to such a set of instructions. That is what the program. So you have the Java program, Java application. So when you learn such a Java application, that set of instruction will be loaded into the where? Memory. So another important part of the computer stuff is the memory. So CPU unfortunately cannot read such an instruction or the data or information. Not anywhere, only from the memory. So memory is the primary storage area. It's a primary storage area for such a instruction and the data and the information that can be accessed by only the CPU. So CPU can access the data. CPU can access the instruction only from the memory. What is the memory? Sometimes it's called the RAM, random access. The memory. Read only. That is wrong. So what is the memory?
Storage.
It's a storage. It's nothing but if you remember, remind that you learned in the microprocessor class. So this memory is like this one, right? The big endian, little endian. Do you remember that? What is a big endian? What is a little endian? I'm not going to. Even though you got confused everything. So memory is a set of
Patience.
address. It's nothing but address. So if you take a look at if you Google it, the old side of memory is like the drum, like this one. It has a lot of like this. It represents what? Binary number, 0 or 1. It's a set of, like for example, the 128, the dot here. So turn around this. Read the 128 bit. Next line, the 128 bit. This is an address, set of address. This is a set of address. Sometimes your professor probably mentioned about this 000 to the FFFF like that. To represent the memory. Memory is nothing but the address. And each of them is an electronic circuit that represents 0 or 1. Okay? Depending on how to organize, like the most significant bit first is a big endian, or the otherwise a little endian, and something like that, but otherwise it's just represent the set of binary number for the corresponding the address. It's address, which means if you know the address of the memory, then the memory return the such a data to the CPU. Because of that, one of the most popular instruction is the move. Move is the between memory and the CPU, CPU to the memory, or CPU to the CPU. Oh, by the way, CPU has also the sum of the storage, which is called it's a register. Okay, so you can store the temporarily such the data to the register, then the CPU actually read the data or the update the data or sometimes the process the data from the register. Okay, but it's very small. So because of that, we need such a primary storage area. Then, problem of the memory
Capacity.
capacity. Okay, it's expensive. So instead, we are usually have the what? Secondary storage. Nowadays, we are using the solid state disk a lot, but traditionally we use the hard disk one. Such as it's the secondary storage is much bigger than the memory, but it's a slow, but it's much bigger. Another good news is it's a permanent device. On that, why? The memory is a volatile, which means if you lose the power, you lose the information. Okay, it's a kind of the cache area. So these are the main component of the computer. Then we have a lot of I/O devices, and also they are connected to the what?
CPU.
Motherboard is this one. Then to put everything. Then they are connected by the bus. So using the bus, we can transfer the data. Bus is like the highway. Okay. So if you see the highway, the main parkway is the 4 lane, but if you see the 95, it's a 6 lane. So the more lane you have, the faster you can drive. So similarly, the bus is like if you are using 32-bit, actually this is nothing but the 32 wire. So at the same time, you can send the 0 or 1, 0 or 1, and 32-bit data you can send. If you are using the 64-bit, at one time you can send the 64-bit a lot fast. So that is the reason I really like the 64-bit computer rather than the 32-bit. However, because of such a difference, so if you are using the 32-bit, the program, that should be different from the 64-bit due to such a characteristic. Okay, so this is the bus by combining this. It's really nothing but wire. Okay, to send such a 0 or 1 the information. So this is the bus. So then we can compare that. So go back to the very basic. I try to use the CPU, the power. I have very nice the 3.6 gigahertz, the Intel CPU. By the way, what does it mean, the 3.6 gigahertz?
Speed processing.
It's the gigahertz means, hertz means what? Frequency, right? How many times? 3.6 gigatimes per second is the, anyway, the CPU and all of these are the electronic device. It has a signal, okay, based on the signal. So at one cycle, we can process it. Some of the instruction we need 2 cycles. Some of them need 3 cycles. Some of them need just 1 cycle. On average, like we can say the 2 cycles we need to process the 1 instruction, which means 1.8 the giga number of instruction we can process a second, which means it's very fast. Okay, because of that we try to see we try to get the CPU or a computer that has a higher gigahertz. Okay, so then anyway, that is the specification of the CPU. Then go back to this. I try to use the CPU power such as this. Then what do we need to do? We need this one, instruction. So that's the only way to that the CPU can process. So we need to use the instruction. Unfortunately, instruction is not easy to code. assembly language. You can do that, okay, as you learn in the microprocessor class and assembly class, you can do that, but it's not easy. So that is called the low-level language or machine language. Okay. Instead, we prefer to use high-level language. In a computer system, computer science, whenever we are talking about high level means it's a human perception. Anyway, so the consumer of the computer is the human being. We try to use as a human being, we try to use such a computing power. So this computer, AI system, machine learning, whatever, they work for the human being. So when we talk about how unfortunately computer, what they are thinking, what they are processing is different from the human being. So this is a machine level, the low level. But we prefer the high level. So when we code, even the programming, high level language, like Java, C, actually C is also high level language, C++, .NET. So these are the high level languages. That's for the human being, human perception. Okay. Then using such a high level language, we can make the source code. Some of the Python code, even though you never learned the Python, so you can understand. Because it's a high level human, it's very close to the human being. Then, unfortunately, the high level language is not possible to be processed directly by the CPU. Okay, so we need to convert into such a low level language that is the compiler. So compiler is another program language that can convert nothing but the high level language to the low level language, like the instruction. And we have as a result of such a compiler, we have what? Executable file. A.out file in case of C. That means it has a set of instruction. It's nothing but sequence set of instruction. Where is it? It's in the secondary storage. Okay, then unfortunately CPU cannot even access the instruction directly to the secondary storage. It needs to what? Access from the primary storage. So we need to do execute, create the process. In the operating system class, we will discuss more about this part. So we need to process we need to create a process on the memory. Then finally, CPU using the address of this process access the instruction. Then using the program counter, we know where is it. Okay, then access the data. This is overall how it works. Then this part in the program. So for example, I equal 1, the j equal 1, then the for I is not like this. So the system out print the I plus 1, I plus j. So I try to print out the two variable, the I equal 1, j equal 1, then the display the plus. Output will be 2, like this one. Do we use the data? Yes. So what kind of data we are using? The one, and this one. These are the data. In other words, the computer, especially the CPU, can understand the instruction. Then, each instruction uses the sub-operand and the value. So that is the data. Then, such a data is not just the data what you think. It should be formatted very strictly. For example, the integer I is a 4 byte of the data somewhere, 4 byte of the data, and is 1, and it has the address. J is somewhere here, and the 4 byte of the data. Then the plus and the concatenate, and there is another, the memory space, and this will be displayed like this. So, computer can definitely need to use such a data. this is a very simple case, but if you remind your data structure class, you probably learn at the node, student node, ID, name, address, like this. Do you remember that? Sometimes you can connect it this way, linked list, or sometimes the what else? Linked list,
List star.
array, and unsorted array, unsorted optimized array, or sometimes tree structure. If you are not sure, so why don't you take a look at your older textbook, there's such a thing. Then at that time, what are they? Don't know. Such a data structure. It's how to organize such information in the memory. It's a memory data structure. So we have used such a data in the computer system and the program languages so far. Okay? Data and the database are not the concept. So we have used. So the problem is if we had like 10 students or 100, it's pretty much enough to keep all of this in the memory. However, what if I have the 1 million of the customer node? They feasible in the memory as we talk about the limitation of the memory. So memory is a limited size, much smaller than the secondary storage, okay, and also expensive. So we cannot keep all of this data in the memory. We have used the data in our program language, in our the computer system so far, but in case we have the very large data, it's not feasible to the memory. So mostly we have used the data in the memory-based database so far. We have used, it's nothing new, okay? In your the Java program, in your the Python program, in your the .NET program, we have used the data. Even from the primitive type of such the integer or sometimes the class, they are the data. It's a database. But problem, if that are feasible to the memory, it's okay. However, nowadays we have bigger and bigger the data. So in case we have the very large data, we cannot use the traditional memory-based database. What will be the solution? So we need to use the benefit of the secondary storage. Okay. So this is the main part of this class. How to organize such a data in such a secondary storage. The problem is, in the memory, as long as we know the address, we can access the data, and also it's very fast. Okay. However, if we are using the secondary storage, we cannot directly access the data to the secondary storage. We need to work with the memory. So this one should have the different organization, different the format, different data structure. So we are going to learn how to organize, how to make the very good, fast data structure for the very large data. Okay, that is